Okay, so this one says you can use this app here to simulate what it would be like to put an object in front of a lens and see what kind of image you'd get. If we were to draw a ray diagram where the object is 4.5 centimeters away from a lens with a focal length of positive 2.5, what type of image would we get? Alright, so I'll go back to that site. And let's see if we can simulate that. It doesn't matter how tall the object is, but we want it 4.5 centimeters away from the lens. I'll put it 4.5 centimeters in front. So if we go over to this side, we could switch it to a diverging lens, concave lens, but we actually want a positive focal length, they said. So I'm going to put it on this side, making a converging or convex lens. Alright, there's 2.5. Let's see if I can get this right to 4.5. There we go. And the height of my object, there we go, there's a height of 1, that'll work. Alright, so what kind of image do we see from this? We see that the light rays go through the converging lens, they bend in such a way that creates an image located 5.65 centimeters behind the lens. They call this side the front, this the back. So I'm going to say, okay, behind the lens. And is it farther from the lens than the object? Yes, that is something we observed. Is it larger than the object? Let's see. Yeah, the height of the image is negative because it's inverted, but it is a bigger size than 1. So it is larger, yes. Is it in front of the lens? No. Is it closer to the lens than the object? No. Smaller? No. Inverted? Yes. And is it upright? No. So we also want to be able to use formulas to solve all these things in addition to drawing the diagrams. So one of the formulas that's really big for this section is going to be, yeah, right here, the thin lens equation. So I'm going to use that. So 1 over SO plus 1 over SI equals 1 over F. And it should be that we plug in these different things. Distance of the object, 4.5. Leave the distance of the image as a variable. And then your focal length, you want that 2.5 there. And we can now solve for SI. And so these are a little tricky to solve. What I typically do is I'll do 1 over the one fraction minus the other, because I'm going to move the other one to the other side. But your SI is in a denominator position, so it ends up being that if you solve it, you'll get this 5.63 or so. So that lines up with what we said, because we said that it would be farther from the lens than the object. And then when it comes to the size of the thing, you can use the other equation, this one here, the magnification. So we have M equals HI over HO, which is negative SI over SO. If I simplify that, I'll get rid of the height part of it and just do this. I can solve for the magnification. So this would be 5.63 over the original 4.5. The magnification therefore becomes about 1.25, but it's negative, so that means inverted because it's negative, and it also means larger image.